All right, let me give you the solutions to assignment 71. Okay, question 1. In each part below, find the positive constant c that makes the quadratic the square of a binomial. Okay, so for the first question, note that we have already had x squared here, and 9/4 is 3/2 squared, right? So we have a squared and b squared. We need 2ab, right? So basically, if we have x plus 3/2 squared, then we will have x squared plus 2ab, which is 2x, then multiplied by 3/2, then plus 9/4, right? So this is our cx, which is 3x. Therefore, the coefficient of xc equals 3. So this is our final solution. Okay, for the second question, note here we should have a squared here and b squared here, right? So basically, you can spend it like this: x plus square root of 96 squared. And then if you expand it, you will get x squared plus 2ab, which is 2x square root of 96 plus b squared, which is square 96 squared, which is 96, right? So this is our cx. So note here, 96 is 16 by 6, right? So this is x squared plus 2 by 4, then by square root of 6x plus 96. Therefore, c equals 8 square root of 6. Okay, any questions? All right. Next question. Final solutions to the equation 5x squared plus 2x minus 1 equals 0. So you could choose either way to do it. You could solve it by completing the square method or by directly using the quadratic formula, right? So let's try using the quadratic formula here. Apparently, the three coefficients are a is 5, right? And b is 2. And this is our c. C is -1. Because this equation here is already in its standard form. So according to the quadratic formula, first of all, we'll calculate the determinant delta, which is b squared minus 4ac, which is 4 minus 4 by 5 by c. C is -1. So here you will get 4 plus 20, which is 24. Then the solutions x is given by this formula. 2a is the determinator, denominator, and negative b, which is negative b, and then plus or minus square root of delta. Then let's put all the numbers in. 2a is 10, right? And negative b is -2. And then positive or negative square root of delta. Delta is 24. Then usually we'll put the perfect square number outside the square root symbol, which is -2, positive or negative. Note here 24 is 4 by 6, right? And 4 is a perfect square number, which can be put outside the square root symbol, which is 2. Then multiplied by square root of 6, then over 10, right? And after simplification, we'll have -1, positive or negative square root of 6 over 5. And this is our two roots. All right, so please have a look at this. Any questions, let me know. No questions. All right, let's move to the next question. Question 3, solve each of the following questions by completing the square. All right, so this question asks us to specifically using the completing square method to solve each of the following equations. So first of all, note here, usually if the leading coefficient is not 1, we can divide both sides of the equation with the leading coefficient, right? So first of all, we can divide both sides using the 4. Therefore, the original equation is equivalent to 4x squared over 4, then 16x over 4, then 24 over 4, then 0 over 4, right? And if we divide both sides using the same non-zero number, the new equation here should be equivalent to the original one. So we only need to solve the new equation here. Their roots should be the same, right? Which means x squared plus 4x plus 6 equals 0. And then we can use a completing square method. So note here we have x squared here, then 4x is our 2ab, right? You need to write this in a form of 2x and something, right? Apparently 4x is 2x by 2. So this is the other number. The other number is 2. So here, this is equivalent to x plus 2 squared. And note that you can always verify your result by expanding it back, right? If you're not sure with your result here, you can expand it back, which gives you x squared plus 2ab, which is 4x plus 4, right? Then you can see here you have x squared plus 4x, which is the same with x squared plus 4x here, right? And you add a 4 into the new equation. There is no such 4, so we need to subtract it from the new equation. And then copy the rest of the equation, right? So the new equation here is exactly the same with this one. These two equations are actually the same, right? Okay, so in this way, the new equation is written as x plus 2 squared, and then we can move all the constants to the other side, which is 4 minus 6, which is -2, right? So something squared is -2. That means we need to solve this in a complex number set, which means x plus 2 is negative or positive, a positive or negative. We have to introduce I, right? Then square root of 2. Again, if you're not sure with the result here, you can just square both sides, right? If you square both sides, this is x plus 2 squared, and right side is I squared times 2, which is -2, right? So that means your result here is correct. And therefore, the final solution is x equals -2, then positive or negative I times square root of 2. Okay. Any questions regarding the first question? No? All right, good. So let's have a look at question B here. Again, if you want to use completing the square, my suggestion is if the leading coefficient is not 1, you can divide both sides using the leading coefficient to make the question simpler. So we can divide both sides using the leading coefficient 6, right? That means 6x squared over 6 minus 3x over 6, then plus 2 over 6 equals also 0 over 6, right? And in this way, this will give you x squared, then minus 1 over 2x, then plus 1 over 3 equals 0, right? And then you can use a completing square method. So note here, this is our x squared, and the second term should be twice of the first, which is x, and something here, right? You need to figure out what you should put here, right? So basically 2x then multiplied by the question mark should equal the term here, right? Which is -1 over 2x. So can you figure out what is a question mark here? Can you tell me what it is? It should be -1 over 4. Yes, it should be -1 over 4. In this way, you will get -1 over 2x, right? So let's try -1/4 here. So we only need to put 1 over 4, right? So the other term should be -1 over 4, then squared. Again, if you're not so sure, you can always verify that by expanding it back, right? If you expand it, you will get x squared minus 2ab, which is 2x times 1 over 4, then plus plus 1 over 4 squared, which is 1 over 16, right? And as you can see here, we have x squared, then -1 over 2x, which is -1 over 2x here. Then you add another constant 1 over 16. So basically we need to subtract it. So there's no 1 over 16, right? Then copy the rest of the equation here. Okay, so the new equation here is equivalent, actually exactly the same with the equation here, right? These two equations are exactly the same, all right? Then for the new equation, we can move all the constants to the other side, which means x minus 1/4 squared equals 1 over 16, right? Then -1 over 3. Okay, so we need to rewrite this with the common denominator, which is 1 over 16 the common denominator of 16 and 3 apparently is 48, right? So 1 over 48, 3 over 48, then minus 16 over 48. So that means x minus 1/4 squared equals -13 over 48, right? All right, so can you tell me what is x -1 over 4? Again, something squared is the negative number, so we need to introduce I here, right? Okay, so it should be square root of 13 over 48, but note here 48 contains some perfect square number, right? Which is 16 by 3. So basically, we need to put 4 outside the square root symbol, which is 13 over 3, right? You see that? Okay, good. So next step is to move the 1 over 4 to the other side. So positive or negative. Remember to rationalize the denominator, which will give us I, then square root of 39 over 12. This is the conventional way to write the final solution, okay? All right, so please have a look at the question here and let me know if you finish, okay? All right, good. Next question. If x is a real number, what is the smallest possible value of 4x squared minus 20x plus 45? Okay, so in our previous lesson, we have discussed something like x squared, right? So this time the leading coefficient is not 1. But this time, this is not an equation. For an equation, usually you will have something equal 0, right? But you don't have the later part here. This is just the expression, not an equation. So you can't just divide both sides because you don't have both sides. You only have one side, right? If you put the common factor 4 outside, you will get 4x squared negative 5x, then 45 over 4, right? The 4 is always there. Do not just cancel this, right? Because if you do not write 4 here, the new expression is different with the original one, right? Can you see that? If you want to convert the leading coefficient to 1, do not forget to put a 4 outside brackets. You understand? Okay, so your 4 is always there. Then you can do something in the brackets. Apparently, this can be rewritten as a binomial squared, right? So here we have x squared, then negative 5x. So the negative 5x should be 2x and something, right? Can you tell me what is a question mark here? So negative 5 over 10, that is negative 1 over 2, right? Okay, so let's try negative 1/2 here. X minus 1 over 2 squared, right? And again, if you're not sure, you can just negative 5 over 10 is not the correct answer, I guess. Can you see why? Because negative 5 over 10 is negative 1/2. If I put negative 1/2 here, you will get x squared minus 2ab, which is x, then plus 1 over 4. You will have a negative x, not negative 5x. You see that? So if you have x squared minus 5x, then what should you put here in order to have a binomial squared? Again, if you're not sure, you can just expand it, right? If you expand it, you will get x squared plus 2ab, which is 2x, then question mark, then plus question mark squared. Do not worry about this because we can subtract it. What you should do is to ensure x squared equals x squared here, and then the second term, 2x question mark, should equal minus 5x. So what is a question mark here? 2x question mark should equal negative 5x. Can you tell me what is a question mark? What should I put here in order to make the two sides equal? So negative 5 over 2, right? So if you put negative 5 over 2, 2 cancels with 2 here, of course you will get negative 5x. Okay, so let's try negative 5 over 2. Okay, let's erase all the writings in the scratch paper. And let's put -5/2. Okay, and again, if you're not sure about it, you can just expand it, right? If you expand it, you will get x squared minus 2a, which is x, b, which is 5/2, right? Then 2 cancels with 2, then you will have -5x, which is exactly the second term, right? So -5/2 is correct. Then do not forget, you add a term, you have added a term 25/4, right? So you need to subtract it in order to make the new expression exactly the same as the original one. Then plus 45/4. You see that? Okay. Okay, so basically this is 4 times x -5/2 squared. Then combine the last two terms, which will give us 45 minus 25 is 20/4, right? 20/4 is 5. And now can you tell me what is the smallest possible value of this number? So let's discuss them one by one. X minus 5/2 squared. What is the smallest number of this expression? Basically, that's something squared, right? Can it be 0? Okay, my question is, can it be 0? (25/4) is not the smallest because 0 is smaller than your 25/4, right? Can it be 0? Of course, yes. And can it be positive? Of course, yes, right? And can it be negative? No, because something squared, if x is a real number, if inside the brackets is a real number squared is always non-negative, right? So according to these conclusions here, what is the smallest number of this expression? Of course, 0, right? Because it can be 0 and it can also be positive. So the smallest possible number should be 0, which means something squared. If something here is a real number, it's always greater than or equal to 0. So the smallest possible value of this expression is 0, right? So how about smallest possible value of something squared plus 5? No, do not consider 4 here yet. Let's do this one step by one step. I'm asking, what is the smallest possible value of this expression in the brackets? If the first part is 0, plus 5, of course, the smallest possible value of the expression here is 5, right? And last, let's consider the whole expression. If the smallest possible value of the expression in the brackets is 5, what is the smallest possible value of the whole expression? You answer that. This time it should be 20, right? Yes. This is the logic behind this question. And now we can make the conclusion. because the expression here is exactly the same with the original one, right? Therefore, we have already discussed the smallest possible value of this expression. So the conclusion is the smallest possible value of 4x squared minus 20x plus 45 is 20, right? Did you get it? Please spend some time, have a look at it. And let me know if you finish, okay? All right, so of course, there is another way to do this. So let me explain this to you. Let's copy this expression blank page. Okay, of course, you don't have to convert the leading coefficient to 1, right? So because 4x squared can be rewritten as 2x squared, right? Then we have the second term, which is if you can write it as 2ab, a is now 2x, right? Then times a question mark. If you can find some question mark here, such that the second term equals 20 minus 20x, then we can also write it as a binomial squared, right? So can you tell me what should you put here in the question mark position? Note here 2x is our a, right? And here we have 2ab, right? Question mark is b. My question is, what is a b? You think it's 5, right? Okay, your guess is 5. B is 5. So let's try 5. So 2x squared, then negative 2 times a, which is 2x, then times 5. Apparently, this will give you 2 by 2 is 4. 4 by 5 is 20. So minus 20x. That's correct. Then we have to put 5 squared, right? Then because there's no 5 squared, we need to subtract it. Then copy the rest of the expression. Okay, so for the first 3 terms, this is exactly our a squared minus 2ab plus b squared. Can you see that? So we can write it as 2x minus 5 squared, right? Can you see that? Again, if you're not sure, you can just expand it. If you expand it, this is 2x squared minus 2ab, which is exactly minus 20x, right? Then plus 25. So that means our transformation here is correct. Okay, so basically the original expression is 2x minus 5 squared, then minus 5 squared, right? Which is 25, then plus 45, which is 2x negative 5 squared, then plus 20, right? And this time we only need to discuss first What is the smallest possible value of the first part? Can you tell me? It is a real number squared, right? So what is the smallest? No. The first part. Can it be 0? You think it's 25, but can it be 0? It can be 0. So 0 is smaller than 25, right? So what is the smallest possible value of the first part? Negative 20. It can't be. So something squared, as long as this number is a real number, something squared is always greater than or equal to 0, right? So the smallest possible value of the first part is 0, right? Can you follow the logic? Yes. And then the smallest possible value of first expression plus 20 is how many? It's of course 20, right? Therefore, you can make the final statement. The smallest possible value of the original expression is 20. Okay. All right, so please spend some time to have a look at the two methods. You can, in the future, you can choose either method you like. Okay, I think the second method seems simpler and more straightforward. Let me know if you finish, okay? All right, let's see the next one. Question 5. All right, this time we'll use the quadratic formula to find the solutions to each of the following equations. First equation, first of all, we need to convert it to a standard form, right? Standard form means ax squared plus bx plus c equals 0, where a is not 0. This is standard form of quadratic equation, right? So first of all, let's put all the terms in to the left or to the right. So if we move all the terms to the left, you will get 3x squared minus 6x minus 1 equals 0. This new equation is equivalent to the original one, right? And apparently the three coefficients are a is 3, and b is -6, and c is -1, right? Next step is to calculate the determinant delta. Delta is defined as b squared minus 4ac, which is 36, minus 4 by a, which is 3, by c, which is -1. So this time we'll have 36 plus 12, which is 48, right? 48 is not a perfect number. So you will expect some square root symbols in our final solutions. Final solution x is given by formula 2a is the denominator and negative b plus or minus square root of delta. Then we can put all the numbers in. 2a is 6, negative b is 6, and then positive for negative square root of 48, right? 48 is 16 by 3, so we can put some number outside the square root symbol. So this is 6, positive or negative 4 square root of 3 over 6. Then after simplification, we'll get 1 plus or minus 2/3 of square root of 3, right? Any questions regarding the first question? No. All right, good. Next question. Actually, you can expand it and convert it to the standard form, right? And another way to do it is to let x minus 1 equals u, because we have x minus 1 squared, and then we have twice of x minus 1, right? So if you regard x minus 1 is u, then the original equation is actually u squared minus 2u plus 1 over 2 equals 0, right? So the new equation here looked simpler, right? If you can solve u, then x is actually u plus 1. Then you can solve for x, right? Okay, so for the new equation, this is our a is 1, and b is negative 2, and c is 1 over 2, right? So according to the quadratic formula, the two, first of all, we'll need to calculate the determinant delta. Delta is b squared minus 4ac, which is 4, minus 4 by 1 by 1/2, which is 2, right? So the two solutions in the equation containing u is 2a's denominator and minus b plus or negative square root of delta. Then let's put all the numbers in. 2a is 2, negative b is 2, then positive or negative square root of 2, right? Which is 1 plus or negative square root of 2 over 2. But note here, you have solved u, but the question asks us the value of x. Note here, x is actually u plus 1, right? So x equals u plus 1, which is 1 plus or negative square root of 2 over 2, which is 1 plus or negative square root of 2 over 2, then plus 1, right? Which is 2, negative or positive or negative square root of 2 over 2. And of course, the other method is to expand everything and convert it to the standard form quadratic formula. You can choose either way, right? Okay, so please have a look at the two questions here, and let me know if you finish. All right, let's have a look at the next one. Find the roots of the equation here. So note here, this time the coefficients are not real numbers, right? It contains the imaginary unit I, but we can still use the quadratic formula to find the roots. So here, A is 3i, and B here is 3, and C is, of course, 8i, right? Then we calculate delta. Delta is b squared minus 4ac, which is 9, minus 4 by 3i, then by 8i, which is 9, plus 4 by 3 by 8, right? Which is 9 plus 96, which is 105. You follow me? Then x is given by the formula 2a is a denominator and minus b positive or negative square root of delta. Then let's put all the numbers in. 2a is 6i. Negative b is negative 3, then positive or negative square root of 105. So 105 does not contain any perfect square number, so we can just leave this number under the square root symbol. But here we usually will need to rationalize the denominator, right? So the denominator should not contain I. So we can multiply both the denominator and numerator with I. So minus 3 positive or negative square root of 105 I, then 6i times I. Then the denominator becomes negative 6, and numerator is negative 3 positive or negative square root of 105i. Then after simplification, we'll get 6 is the denominator, 3, then plus or negative square root of 1/5i. All right, so please have a look at this question and let me know if you finish, okay? All right, let's have a look at question 7. If one root of the quadratic equation that has real coefficient is 3 minus 4i, what is the other root? Question B, if one root is a quadratic equation that has rational coefficients is 2 plus square root of 3, what is the other root? So both of the questions ask you that if one of the roots is given, what is the property of the other root? So let's consider the quadratic equation ax squared plus bx plus c equals 0, right? Where a is not 0. So for question A, if one root of, if the quadratic equation has real coefficients, that means, or A, B, C here are all real numbers, right? If all of them are real numbers, note that the roots are given by the equation here, right? So can you tell me if one of the root contains imaginary unit I, where the I can appear? Can it appear here? No, because A and B are real numbers, right? It can only appear in this part, right? Understand? Okay, so that means the root will have the form something I over 2a, right? Okay, so if one of the roots is 3 minus 4i, can you guess what is the other root? This is the real part, right? The real part is the same, but the imaginary part is the opposite. So the other root must be 3 plus 4i, right? Note here, if you have imaginary units, yes, The reasoning is correct because if you have imaginary roots, then the two imaginary roots will be conjugate. Okay, so remember this conclusion. If you have two imaginary roots, the two imaginary roots will be conjugate to each other. Okay, so for the second question, again, let's consider the quadratic equation here is not zero, but this time all the three coefficients are rational coefficients. That means A, B, C are all rational numbers. Rational numbers can be expressed as a fraction over two whole numbers. Understand that? I hope you can still remember the definition of rational numbers. Rational numbers can be expressed as a fraction. So again, let's consider the solutions. X is 2a the denominator and minus b, then positive or negative square root of b squared minus 4ac. And it tells you that one of the root has 2 plus square root of 3. So here we have a square root symbol here. So can you tell me, similar to the previous question, can you tell me if you have a square root symbol, can it appear here? Can it occur here? Of course, no, right? Because there is no square root of b in b or a, because b and a are all rational numbers. Rational numbers cannot contain square root symbol after simplification, right? Because, for example, square root of 2 is not a rational number. Square root of 3 is also not a rational number. Rational numbers cannot be expressed as something under a square root symbol after simplification, okay? Then my question is, can it appear here? Of course, yes, right? Because apparently you have a square root symbol here. All right, so basically, if you have one root like 2 plus square root of 3, can you guess what is the other root? So according to this form, you will have something under square root, something like this, right? And if one root is 2 plus square root of 3, can you guess what the other root is? It must be 2 minus square root of 3, right? Because as you can see here, if one of the root is minus b plus square root of something over 2a, the other root is negative b minus square root of something over 2a, right? So if one of the root is 2 plus square root of 3, the other root is, of course, 2 minus square root of 3. This is the whole reasoning process. Okay. All right, so please look back to this question again and let me know if you finished, okay? All right, let's have a look at the last question, which is an extension to question 7. You are given a quadratic equation, right? And you are also given one of the roots, which is 4 minus square root of 5. And you are also given that a and c are rational numbers. So this is our a, this is our c. Both of them are rational numbers, which means they can be expressed as a fraction, such as p over q, right? And also, or b here, or coefficient b here equals 1, which is also a rational number, right? And if all the coefficients are rational numbers and one of the roots is 4 minus square root of 5, can you tell me what is the other root? What is the other root? According to our analysis in our previous question, it should be 4 plus square root of 5, right? Okay. And according to the quadratic formula, you still remember that conclusion? The sum of the two roots equals what? Remember that? Can you tell me the sum of the two roots is negative b over a, right? We have already learned this. So negative b over a is negative b is 1. A is unknown, so just keep a here. And apparently x1 is 4 minus square root of 5. Then x2 is 4 plus negative square root of 5. So this will give you 8. So according to this equation here, a can be solved to be negative 1/8, right? Can you see that? So this is the value of a. Can you follow me? Okay. And in order to solve C, we can use this conclusion, right? The product of x1 and x2 should equal, can you tell me what it is? C over a, right? Okay, C is unknown, so just keep C there. And a has been solved to be negative 1 over 8. And x1 is given. x2 is implied to be 4 plus square root of 5. So first, let's calculate the product here. A plus b times a minus b is a squared minus b squared, which is 16 minus 5, which is 11, right? And then according to this equation, we can solve that c should equal negative 11 over 8. Can you see that? Any questions? Okay, I'll put my notes onto Google Classroom, which you can refer to if you like after the class, okay? And I'll let you know when the next assignment is available. And if you have no questions, you are free to go. Okay, have a nice day. Have a nice evening.